Hello everyone. Now I would like to introduce a little of my code in this project. So firstly, this is the main function, and this path is the new CSV file we want to generate, which contains the 6 elements of all the sentences in the file. And this path 1 is the path for reading the parse tree, and this path 2 is the path for reading the prop bank. So we open these two files and we read each line in one iteration, and this count is a variable that we use to count like which line we are reading in the parse tree corresponding to the current sentence. And this out is a list containing the 6 elements that we want to output, and this words list can store all the words in a single sentence, and this line stores all the lines in the parse tree corresponding to one sentence, and this band stores the intervals regarding to those unimportant chunks which I mentioned in the paper. And these stacks are used to track a chunk using a stack method, which I will introduce later. And this temp and log stores the intervals, which contains the time information elements and the location elements in the sentence. And here are some flags and signs. So here we read a line in the parse tree, and this read is a line that we have read. And if the line is not null, it means that there are some remaining sentences in the current parse tree file, so we need to keep reading. And if the line that we read is enter, that means we have finished reading the current sentence, and we need to do the extraction and output the 6 elements. So this is the first situation, but we don't look at this situation. Now we want to look at the else situation. So else here means that the current line that we are looking at in the parse tree is not an enter. So there are some remaining lines in the parse tree of the current sentence. So if it is this situation, we need to add the word of this line to the words list. And we want to find out if the current line is the beginning of a chunk that is unimportant. So in order to find out it, we need to see if the current line has the following tags. So this SBAR means that the current chunk is a clause, and this ADV means that it is an adverb phrase, and this TMP means that it contains the time information, and this log means that it contains location information, and this ADJP means that it is an adjective phrase, and this DIR means it contains location information, and this PRP means that it contains some motivation information. So a chunk with these tags are unimportant chunks, so we need to add them into the band list, meaning that we will not use the predicates in these chunks in the prop bank. So in order to find the chunk, we need to use this track interval function. The function is defined here because when we see a chunk with the text above the text that I mentioned just now in the parse tree, it means that this chunk begins here, but we need to find the whole chunk. So we need to use a stack method. The reason why we want to do that is that we have a parse tree. We have a parse tree like this, so it contains many brackets. So this is a left bracket, and this is a right bracket, and we just if we find that the number of left brackets is same as the number of right brackets, So we can see that we have extracted the whole chunk. And we can do this using a stack method. So this is basically a stack method. So now we have found out all the unimportant intervals, but we also need to see whether this chunk is tagged by temp. So if it is tagged by temp, that means it contains some time information. So we need to, get the whole chunk as our time elements. And we want to see if the current chunk has this location information and direction information. If so, we can extract the whole chunk and use it as our location element. So the method that we use to extract the whole chunk is also this track interval function. And after we do that, we add 1 to this count, meaning that we will read the next line of the parse tree and we read the next line. So if we find here, if we find that the current line that we are looking at is entered, it means that we have finished reading the current sentence and we need to output all the elements. In order to do that, we need to read the predicates in the prop bank. So we want to extract the current line in the prop bank, which is line 2 here, and the sequence number is the number of sentence that the predicate that we're looking at right now is in, and we want to find out whether this sequence number corresponds to the right sequence number of the sentence in the parse tree that we're looking at. If the two number equals, we can know that we are looking at the predicates of the current sentence. So we can continue our processing. But if the predicates we are looking at does not belong to the current sentence, we need to do this continue and read the next predicate until it is in the current sentence. So we can see that this right is actually the number of the sentence that we are currently looking at. So next, we want to find out whether this predicate that we are looking at is in the unimportant parts of the sentence. So we do this checking, and if it is in the unimportant part, we need to turn this sign into 1, and we want to read the next predicate because the predicate in the unimportant part cannot be used. So after we have done these checkings, we can see that the current verb is usable, and we want to find out, in this part, we want to find out how many arguments are related to this verb. And we want to, because there can be many situations. For example, this verb can have 1 argument 0 and 1 argument 1, or 1 argument 1 and 1 argument 2. So for each specific situation, we have a specific rule to do the processing. So we need to find out here how many, the number of each argument are related to this verb. So here we also want to find out if this verb has any argument that is tagged by the manner or purpose or course. If so, we can know that we can extract some, a method element or motivation element by looking at this verb. So here we do a judge. We want to see if this verb has enough arguments. If it does not have any arguments, it cannot be used, and we need to read the next predicate. So for this part we just have so many rules, because the number of elements that is related to the current predicate can have different situations. So for each situation, we have a specific rule to extract the predicate, to extract the subject and the object. So after we have extracted the subject and object, we just put it into the out list. And in the ProBank, it only gives the beginning position of the subject and object, but actually in most occasions the subject and the object can have many words. It is a big chunk. So when we have the beginning situation, we can use this track argument function to track the whole subject and object. So it is like this. We also use a stack method. So but it is a little different. Here we need to find the whole chunk, and we need to join all the words in this chunk at the string, and we put the string into the out list as our subject and our object. So for this part, if we have find that this predicate has some arguments that is tagged by the manner or some like purpose and the cause tag, it means that it has some motivation or method element. So we also use this track argument function to track these arguments as our method or motivation elements. So here is actually so for this part, it is actually used to track the passive voice, because as I mentioned in the paper, if you see string like this, it means that we have a passive voice, and we need to track back and find the first long phrase before the verb as our object. So here means that, so this NN means a long phrase, and we just need to find the whole phrase, which is a whole chunk for this noun, and use it as our object. So the tracking method is also a stack method, which is here. So we get the whole long phrase as our object in the passive voice. So here we just get the original sentence, because we need to put the original sentence and the 6 elements we extracted in the output file for us to do the contrast. And here is actually a part for outputting the 6 elements, and we write it here in the output file. So here we do the initialization of all the verbs, of all the variables that we use, because we have finished processing one sentence, and we need to make these variables ready for processing the next sentence. So we need to initiate them. Okay, so this is basically the whole program that I developed for this project. Thank you so much.